Today we will be covering Lesson 17-5 on classifying systems of equations. This lesson will be split into 3 separate sections. We will cover questions 1 and 2, questions 3 to 6, and then question number 7 by itself. Let's go ahead and take a look at our learning targets for today. Our first learning target says, determine the number of solutions of a system of equations. So we have determine number of solutions. Second, classify a system of linear equations as independent or dependent and as consistent or inconsistent. And this would be classify a system of linear equations. Now, we've talked in previous lessons, there are 3 different amounts of solutions. We could have infinitely many solutions. We have no solutions, or we have one solution. Let's take a look. When a system of 2 linear equations and 2 variables is solved, 3 possible relationships can occur. 2 distinct lines that intersect produce one ordered pair as a solution. 2 distinct parallel lines that do not intersect produce no solution. And 2 lines that are coincident produce the same solution set, an infinite set of ordered pairs that satisfies both equations. The 3 systems in the chart represent each of the possible relationships described above. 2 intersecting lines looks as such, has one solution. 2 parallel lines looks like this, no solution. And 2 coincident lines, which is the same line, has infinitely many solutions. 1. Use the system 4x minus 2y equals 21 and y minus 2x equals 10 to answer parts A through D below. A. Write each equation in the system in slope-intercept form and compare the slopes and y-intercepts. So we have 4x minus 2y equals 21. We want to solve for y. So we're going to add 4x. So I'm left with negative 2y equals 4x plus 21. Next, we're going to divide by negative 2. So this is going to give me y equals negative 2x minus 10.5. That's the first equation. Let's take a look at the second one. Y minus 2x equals 10. So we need to add 2x. Y equals 2x. Oops, I gotta go back. Sorry. Plus 10. I need to go back because over here I should have subtracted the 4x and not added it. So let's go back and make that small edit real quick. So that makes this minus 4x minus 4x. So right here we would have a negative. And we already know that a negative divided by a negative is a positive. So my slope of the first equation is positive 2. My slope of the second equation is also positive 2. My y-intercept, or my b, is negative 10.5. My b over here is positive 10. So I notice that the slopes are the same, but the y-intercepts are not. Make a conjecture about this graph and the solution of the system. How many solutions do we think we're going to have, and what do we think these lines are going to look like with this graph? This is going to be 2 parallel lines and we will have no solutions. So these lines will not touch. Okay, it says check the conjecture from part B by graphing the system. I'm actually going to graph this in Desmos so we can see it. The first equation was y equals 2x minus 10.5. The second equation was going to be y equals 2x plus 10. Notice these lines are running at the same slope, but they have different y-intercepts. So even if I shrink these down, they're never going to touch. They're always going to just be parallel. So I used Desmos here to verify that they did come out to be parallel lines. It says solve the system using either the substitution method or the elimination method and describe the result. Well, we have both equations set equal to y, right? So I'm going to use the substitution method and I'm going to set them equal to each other. So we would have 2x minus 10.5 equals 2x plus 10. We would subtract 2x from both sides. I'm left with negative 10.5 equals positive 10. Is this a true statement? Since this is not true, that means we will have no solution, because the statement is false. All right, let's take a look at number 2. Use the system 2x equals negative y plus 1 and 6x plus 3y equals 3 to answer parts A through D below. Write each equation in slope in the system in slope-intercept form and compare your slopes and y-intercepts. All right. We have 2x equals negative y plus 1. So I'm going to subtract 2x from both sides. But I'm also going to add y. That puts my y on the left-hand side, which is how I like to write it. And this is going to be equal to negative 2x plus 1. All right, it says write this one in slope-intercept form. So we have 6x plus 3y equals 3. So we're going to subtract 6x. We've got 3y equals negative 6x plus 3. We would divide by 3. This gives me y equals negative 2x plus 1. What's my slope here? Negative 2. What's my b here? Positive 1. What's my slope over here? Negative 2 again. And my b? Positive 1. Make a conjecture about this graph and the solution of the system. So, I've talked about parallel lines. Do you think this one's going to be intersecting, or you think these are going to be my coincident? That's right. This is two coincident lines, and it will have infinitely many solutions. Part C says, check the conjecture from Part B by graphing the system of equations. All right. Even if I plug in the original equations, which was 2x equals negative y plus 1, and this one was 6x plus 3y equals 3. I want you to notice something. I turned them off and on, and there's only one line. It's the same line. So that does check out with what we said. So use Desmos here. It says solve the system using either substitution or elimination and describe your result. Well, because I've already solved them for y, we've got y equals this, y equals this. Let's just set those two y equals to each other. So I've got negative 2x plus 1 equals negative 2x plus 1. Add 2x to both sides, and these would cancel out, right? So I got 1 equals 1. Is that a true statement or a false statement? That's true, right? So this is going to give us infinitely many solutions. Because this statement is true. On to the next set of questions.